All right, let's get into it. Today, we're demystifying a really big topic in the world of IVF. That's PGTA, or preimplantation genetic testing. If you're on a fertility journey or you know someone who is, this explainer is all about giving you some real clarity on what can be a super complex and emotional decision.
So here's what we're going to cover. First, we'll talk about the biggest, often unseen hurdle in IVF. Then, we'll decode what genetic screening actually is. We'll look at the incredible promise of PGTA, but also get real about the risks. And we'll wrap up with the single most important takeaway, seeing it as a tool, not a sure thing.
Okay, so first up, let's talk about why IVF can be so tough. You know, it's a total marathon, physically, emotionally, financially. And one of the most gut-wrenching parts is when an embryo that looks absolutely perfect under the microscope just doesn't result in a healthy pregnancy. And that leads to this huge question: why? Why does a beautiful, healthy-looking embryo sometimes fail to implant? You do everything right, you follow all the instructions, you get your hopes up for the transfer, and then it either doesn't work or it ends in a miscarriage. The reason for that is often something we can't even see.
And that invisible reason? It's all about the chromosomes. An embryo can look like a textbook example of perfect development, but on the inside, in its genetic code, if the number of chromosomes is off, a healthy pregnancy just isn't possible.
The scientific term for this is a numerical abnormality, or you'll often hear the word aneuploidy. So, a healthy human embryo is supposed to have exactly 23 pairs of chromosomes. If it has even one extra or one missing, that's what we call a numerical abnormality. And honestly, this is the leading cause of both failed IVF cycles and early miscarriages. It's a massive hurdle.
So, if this invisible chromosome issue is such a big problem, is there anything we can actually do about it? And that question leads us directly to the technology that was created to tackle this exact challenge.
And that technology is PGTA. It's a mouthful, right? Preimplantation genetic testing for aneuploidies. But let's just break it down. Preimplantation means before it's transferred. Genetic testing is pretty straightforward, and aneuploidies is just that fancy word for an abnormal number of chromosomes. So it's a test to count the chromosomes in an embryo before you transfer it.
So how does this actually happen? Well, first, your embryo grows in the lab for about 5 or 6 days until it reaches a stage called a blastocyst. Then, a highly skilled embryologist comes in and performs a tiny biopsy, carefully taking just a few cells from the part that would eventually become the placenta. Those cells get sent off to a genetics lab, and the results come back to help you and your doctor choose which embryo has the best shot.
Okay, this is a really important point we need to clear up. When you hear words like testing and selecting, it's easy to think we're somehow changing the embryos. So let's ask it directly. Does this test do anything to alter or fix an embryo's DNA?
And the answer is a hard no. Absolutely not. PGTA is only a test. It doesn't change, edit, or repair anything. It's purely informational. Think of it like reading the ingredients on a food label. You're just gathering information to make a choice. You're not changing the recipe.
So if it's just a test, what's the big deal? Why would people choose to do this extra and, let's be honest, pretty expensive step? Well, let's get into the potential benefits, or the big promise of PGTA.
The thinking here is pretty powerful. By only transferring embryos with the correct number of chromosomes, the idea is to boost your chance of success for every single transfer. That means potentially fewer cycles, which is huge. It's about lowering the heartbreaking risk of miscarriage and avoiding the transfer of an embryo that never had a chance to begin with. And if you're fortunate enough to have a few embryos, it helps you pick the one most likely to succeed.
And this chart, wow, this really spells out why this is such a big part of the conversation. See, the risk of having those chromosomal abnormalities isn't the same for everyone. It goes up, and pretty steeply, with maternal age. For women over 40, that risk can be over 80%. That means more than 8 out of 10 embryos might have a chromosomal issue. That's a staggering statistic.
But, and this is a really important but, it's not a magic wand. Like any medical procedure, there are risks, and we absolutely have to have a balanced, realistic look at the drawbacks and what this test can't do. It's truly a balancing act. On one hand, you have the hope of a higher success rate per transfer and a lower risk of miscarriage. But on the other hand, you have to weigh the cons. There's a very small, but not zero, risk to the embryo from the biopsy itself. It adds a pretty significant cost to an already expensive process. And you have to be ready for the very tough possibility that the tests come back showing that you don't have any chromosomally normal embryos to transfer.
Which brings us to the single biggest reality check of all. Let's say you go through with it, and you get the incredible news that you have a chromosomally normal or euploid embryo. Is that it? Is a baby guaranteed? No, it is not a guarantee. And this number is maybe the most important one to remember. Even with a tested, chromosomally normal embryo, the average chance of a live birth from that transfer is still around 50 to 60%. That's a huge improvement for sure, but it also tells us that having the right number of chromosomes is just one piece of a very, very complex puzzle. And that right there is our final and most crucial takeaway. It's all about how you frame PGTA. It is a powerful information tool. It is not and never will be a guarantee.
I think this quote really says it perfectly. The point isn't to promise you a baby. The point is just to help you and your doctor learn more about your embryos. That information then lets you choose the one that seems to be the healthiest, which hopefully shortens your path to a successful pregnancy.
So let's just hammer this home one last time. What is PGTA? It is an information tool. It is a selection method. What is it not? It is not a guarantee of a baby, and it is not a way to fix, change, or edit embryos. Keeping that difference crystal clear is the absolute key to having realistic hopes and making a choice that feels right for you. In the end, all PGTA really does is give you more information to work with on what is an incredibly difficult path. That information can definitely help tip the odds in your favor, but deciding to use it means weighing all those potential pros against the very real financial and emotional costs. So the real question isn't just about the science, it's about you. Is getting more information the right choice for your journey?